This lesson is on solving quadratic inequalities, and I have the steps here. Just like if it were an equation, you want to set this to 0. So over here you have a quadratic. You can tell it's quadratic because of the x squared. You want to be on the lookout for that, and so you're going to set it to 0. You're going to move this 15 term over to the left. So 2x squared minus x minus 15 is less than 0. Don't forget to write that less than 0 down. That matters. You have to have a left and a right side. Then you're going to factor. Most often these are going to factor, although we'll do one that doesn't factor. And so remember, we're going to check the factors of 2, 2 and 1, and check the factors of 15, 1 and 15, and 5 and 3. If this factors, it'll factor into two binomials. Again, don't forget to write that less than 0 down. So 2 and 1, that's the only choice we have, so I can be pretty firm about that. And then we have to check our outer terms and our inner terms. And remember, I said start with the numbers closest together, and we want them to subtract, the outer terms and the inner terms to subtract to be 1. I'll deal with that negative in a minute. And so if I put 3 here and 5 here in the front, I get 6x and 5x, and they do subtract to be 1. Now I need to think about, alright, I need it to be a negative 1, so negative 6x plus a positive 5x is what gives me a negative 1. So we want the 6x, which is made by the 2x and the 3, to be negative, and the 5x, which is made by the 5 and the x, to be positive. Step 3 is you're going to find the zeros. So temporarily we are going to forget about this less than, and we are just going to find the zeros. So 2x plus 5 equals 0, and x minus 3 equals 0. Okay, I'm going to come back to that, but we're finding the zeros. This is where people make a mistake. They carry that over to these linear equations, and you don't do that. We'll deal with that in a minute. So this one 0 is going to be negative 5 halves, and the other 0 is going to be 3. Okay, this is where this parabola crosses the x-axis. Alright, so now a number line is going to be drawn, and you're going to include the zeros that you just found. This is kind of like the x-axis, and then remember how I said this was going to come back? I like to write that less than 0 right at the end because I'm going to analyze how every x value makes the function behave. So I'm going to put negative 5 halves down, and I'm going to put 3 down. And this gives me my test intervals. I've got 3 test intervals. This is all the numbers in the world, all real numbers, divided up into negative infinity to negative 5 halves, negative 5 halves to 3, and 3 to infinity. And I want to check the behavior on the left side of this negative 5 halves. But before I do, let's analyze this part. If it says less than as opposed to less than or equal to, then you don't get to include these zeros, because this is where the numbers that make it equal 0, and it doesn't say less than or equal to, so open hole. Now, to analyze this test interval, I'm just going to pick a test point in here. This is how I do it. So I'm going to pick negative 3. Clearly that's to the left of negative 2.5. And I'm going to put it in here and check the signs. So if I put 2 times negative 3 in, I get a negative 6 plus 5, which is a negative 1. I don't really care about the negative 1 part. I care about the negative part. And then if I put negative 3 in here, negative 3 minus 3 is negative 6. And a negative times a negative is a positive. So what that tells me is that every x value to the left of negative 5 halves, no matter what, if I plug in here, I'm going to get a positive value. Then I'm going to do the same thing for this middle interval. We'll pick 0, and I'm going to put 0 in this binomial and get 5, so that's a positive. Put 0 in that one and get a negative, and a positive times a negative is a negative. Alright, I'm going to pick a number here in this interval and test this interval out. If I put a 4 in here, I get 13, which is positive, and then 4 minus 3 is positive. And a positive times a positive is a positive. Now here's why I don't really care about values. See, I'm analyzing this less than 0. Numbers that are less than 0 are negative numbers. So I don't really care about the values, I just care about the signs. Numbers that are greater than 0 are positive numbers. I want numbers that are less than 0. That's this negative here, so that means I can shade this answer. And then the last thing is you write your answer in interval notation, and since it's open hole, parentheses, comma, -5 halves, comma, 3 parentheses is your final answer. Any numbers in between -5 halves and 3 will give you a true statement, a correct solution. All right, let's look at the next one. So we have 3x squared plus 7x minus 20 is greater than or equal to 0. Step 1 is done. All we have to do is try to factor this. So we know 3 times 1 is all we can get. So I'm going to go ahead and put 3x and x. And then I'm going to check the factors of 20. 1 and 20, 2 and 10, 4 and 5. And because there's a number here and a one there, you've got to check the outer and inner terms. Okay, so I'm going to try the numbers that are closer together again, 4 and 5. And I'm just doing it in my head, and I know that I need this 4 to be here to give me 12x, and this 5 be here to give me 5x, and they need to subtract to be 7. 12x minus 5x is 7. So if you do this method enough, you'll be able to start to do it in your head a little bit. Okay, now I want the 7 to be positive, so I need the 12 to be the positive, 12x to be positive, and the 5x to be negative. That 12x comes from 3x times 4, and this 5x would be negative. Alright, next you're going to find the zeros by setting this equal to 0, these factors equal to 0, and I get 5/3 and -4. Next, we're going to set up a number line so we can look at our test intervals, and we're going to analyze greater than or equal to 0. So my test numbers are -4 and 5/3, and I get to include them this time because these numbers are what make the function equal 0 and the equation equal 0, and we have that less than or equal to. And then my test intervals are -∞ to -4, -4 to 5/3, and 5/3 to infinity. So I'm going to pick a number that represents all the numbers to the left of 4 and just do some sign analysis. Because anytime you've got it to 0, greater than or equal to 0, or less than 0, it just means negatives are positive. So I'm just doing sign analysis. So if I put a -5 in here, I get a -15 minus 5. That's a negative. And if I put -5 in here, I get another negative. And so a negative times a negative gives me a positive. So every x value that you plug in is going to give you a positive number if you were to multiply that out. Alright, the middle number, we can pick the number 0 to represent, and that would be a negative times a positive, which is a negative. 5/3, let's try 2. 2 in here, that would be 6 minus 5, that's a positive. 2 plus 4, that's 6, that's positive. So that's positive. And so now we're done with the sign analysis in that we know how every number in the universe behaves, and we want the numbers that come out to be greater than or equal to 0. So greater than 0 would be here and here. And then we write that answer in interval notation. So that would be -∞ to -4, that interval, and then this interval, union bracket 5/3 to infinity. This next one, x squared is greater than or equal to 9. Some people might try to do this. And that is very wrong. Don't do that. So maybe if I demonstrate it, you won't do that. Your steps aren't going to change. The inequality makes it imperative that you set it to 0 so you can do sign analysis. So that would be x squared minus 9 is greater than or equal to 0. And then that's a difference of two squares. A difference of two squares factors into a product of a sum and a difference. So you don't have to guess and check there if you notice that's a perfect square. This factors into x plus 3, x minus 3. So then I find my zeros, take a time out from that. You can find your zeros in your head if you want. The zeros are negative 3 and 3. And then you do a number line. And that creates test intervals. And I'm going to write down this greater than or equal to 0. I'm going to analyze that just a second. Alright, so I have three test intervals. Negative infinity, negative 3, negative 3 to 3, 3 to infinity. Alright, so sign analysis means just pick a number to represent all the numbers to the left of negative 3 and plug it in here. And so you get a negative 4 plus 3, that's a negative, and a negative 4 minus 3, that's a negative, and a negative times a negative is a positive. If you put 0 in here, you'll get a 0 plus 3, that's positive 3, 0 minus 3, that's negative 3, positive times a negative is a negative. Alright, put maybe number 5 in there. 5 plus 3 is a positive 8. 5 minus 3 is a positive 2. Positive times a positive is a positive. We want whatever x values I put in, I want them to create a value that's greater than 0 or equal to 0. So I can color in the zeros because they're equal to, and the places where it's greater than 0 are here and here. So that answer would be negative infinity, negative 3, bracket, union, bracket, 3 to infinity. Alright, now real quick, you might notice that the signs always alternate. And the reason is because there's another way to do this problem. Once you set this to 0, notice that this is a quadratic, and if you were going to graph the related quadratic function, that would be like an open U that's opening up. And you still need to find the zeros, so we found the zeros. Once you find the zeros, if you want to draw a U-shaped graph that's opening up, then you can see, like we did in Unit 1, this part of the graph to the left of negative 5 halves is above the x-axis, so that's a plus. And this part of the graph is below the x-axis, so that's a negative. And this part of the graph is above the x-axis, so that's positive. So graphing that quadratic on a number line would work. However, I'm going to skip and go to this one since it's right in our good train of thought. Be careful because you might have a negative x squared and then it wouldn't open up. Let's set it to 0 first. So we have to add 7. So negative x squared minus 2x plus 15 is greater than 0. Alright, now I don't recommend trying to factor with a negative 1. I just never like that a value to be negative. So I'm going to manipulate this, and you have to be algebraically correct when you do it. It is legal to divide both sides by negative 1. That is legal. However, you're going to get x squared plus 2x minus 15. Do you remember what you have to do when you divide by a negative number, when you have an inequality? Yes, you have to switch the sign. So be aware of that issue. And again, if you're not writing this less than 0 on all these problems, if you're just writing that, you're a candidate to get it wrong. An equation has to have a left and a right hand side, and you tend to mess up when you don't write both of them. Alright, now we're going to factor. This is an easier one to factor because it understood 1, so we know that's x and x, and we're just looking for the factors of 15 that subtract to be 2, so that's plus 5 minus 3. So my zeros are negative 5 and 3. Okay, so if we draw a number line, and then remember we're analyzing less than 0, you can graph this, but don't graph that one. You changed it. So graph that. It's going to be open holes on the zeros, and this parabola is going to open up. Not this one, but this one. And that's a plus, and that's a minus, and that's a plus. And we want the values to be less than 0, negative. So we want this middle interval. So the answer here would be parentheses -5, comma 1 parentheses. Alright, so the last one, 5x squared minus 30x greater than or equal to -15. Got a lot going on here. First thing we want to do is set it so that the right side is greater than or equal to 0. Alright, next we want to factor. So notice that 5x squared, 30x, 15, 5 goes into all three of that. So I can make this a lot easier if I just factor out that 5x. So that's 5x minus 6x plus 3. And then I could try to factor again, but the factors of 3 are 1 and 3, and they don't add up to be 6, so this doesn't factor. So what do you do then? Well, let's divide out this 5. This constant doesn't do anything but vertically stretch, doesn't change the 0, so I can divide it out legally. And I can't factor, as I said, so is there another way that we could solve for x? So we're trying to find the zeros. So we have to use quadratic formula. So the quadratic formula, you have to have that memorized. Negative b, so that would be positive 6 plus or minus the square root of b. Negative 6 squared is 36. I like to do that in my head. Minus 4 times 1 times 3. All over 2 times 1. Okay, that's going to give me x equals 6 plus or minus, let's see what this gives me. 36 minus 12 gives me 24. Square root of 24 reduces to 2 root 6. Divide that 2 out, and you get 3 plus or minus root 6. Okay, so I mean, we want our answers to be exact, but they're just numbers. 3 minus square root of 6. I think I hit the wrong thing. 3 minus square root of 6 is approximately 0.55. 3 plus the square root of 6 is approximately 5.44. So they're just numbers. I'm not going to write out the decimals because I don't want the decimals. This is not a word problem. I want exact answers. But I know that 3 minus the square root of 6 is on the left and 3 plus the square root of 6 is on the right. And I'm analyzing greater than or equal to 0. So I'm going to color in these circles. And you could use your test points, or you could know that this right here is a parabola that opens up. So this will be a plus, and this will be a minus, and this will be a plus. And we want the numbers that are positive since it says greater than or equal to 0. So the solutions to this inequality are these two test intervals here. So negative infinity to 3 minus square root of 6, bracket union, bracket 3 plus the square root of 6 to infinity. Alright, so really you should, if you know how to divide out by -1 and remember to switch the signs, your parabolas are always going to open up. And we'll expand on that later, but right now that's pretty much it. Just remember to get it to 0, find the zeros, number line, sign analysis, shade the proper test region, and then write your answer in interval notation.